We're not going to talk about reactions of alcohols and thiols. Just as a reminder, alcohols are an OH group bonded to a carbon chain, and thiols are an SH group bonded to a carbon chain. So the first thing we're going to discuss is dehydration. Now, dehydration is a very common term that we hear a lot in the media and especially in sports because of the fact that when you exercise, you get dehydrated. Well, dehydration means that here's water. Dehydration means that you're losing water. So when we're looking at an alcohol, where we want to get rid of an H2O, which means two hydrogens and an oxygen. Well, here's an OH group, and here's another hydrogen. That's the water. That's what's going to be given off. Instead, what's going to happen are these two electrons that were holding these bonds together are going to end up getting connected and form that double bond. Now we're going to talk about oxidation. Oxidation is the act of increasing the amount of bonds to oxygen. So keep telling yourself that when you're looking at oxidation. For instance, we have one bond going to oxygen in a primary alcohol. Notice that specifically says primary. Okay, so here's our carbon and OH group. Hydrogen, hydrogen, one other carbon. The fact that it's one other carbon is what's making it a primary alcohol. Every time you oxidize, you end up losing two hydrogens and you're gaining an oxygen. So you're either losing hydrogen or gaining oxygen bonds. So you're losing hydrogen or gaining oxygen bonds. So here we did both. We lost hydrogen. There used to be an H here and an H down here. And we gained another bond to the oxygen. That formed an aldehyde in the process. This right here is an aldehyde. Now if we try to oxidize that primary alcohol again, remember this is the same thing. This is just this compound rewritten. We're going to oxidize again. When that happens, we're going to increase the oxygen and making it a carboxylic acid. We didn't lose a hydrogen in the process, but we did increase the oxygen. Remember, it's an either or maybe both. Let's look at the secondary alcohols. Alright, so here's our alcohol. We have two carbons that it's bonded to. This is a hydrogen, so that doesn't count in the process. That's why it's a secondary alcohol. The first step is to remove the hydrogens and increase the oxygen bonds. So here's the increase in oxygen bonds, and there's no more hydrogens on there. Now notice that this is now a ketone. The double bonded oxygen's in the middle now. Notice also there's no hydrogens down here. Because of that, we can't go the next step. This step here, once we had the double bond oxygen, we had that hydrogen still there, and we can insert another oxygen and make an OH group. We don't have that luxury here. So this is where it stops. And then finally, if we had a tertiary alcohol, we're surrounded by carbons. There's no hydrogen here at all, so we can't remove any hydrogen to add another oxygen bond there. That would make 5 bonds on carbon, and that won't work. So there's no reaction. This won't oxidize. So, as a summary, oxidation, increase the carbon-oxygen bonds, decrease hydrogen. In the reduction process, you're going to reverse that. You're going to decrease carbon-oxygen bonds and increase hydrogen. So this is just an overview. This is just an alkane. But if this was a primary alcohol, if we were to oxidize it, we're going to increase the number of bonds to the oxygen and remove the hydrogen in the process. This is H2, this is H1. There's an H here, there's no H here. So we removed hydrogen and increased oxygen. Do it again and we have an OH group. We increase the number of bonds to oxygen again. When we go backwards, when we reduce the number of oxygen bonds. So it went from an OH to a regular H. Just to give you a little bit more background, this is methanol, or methyl alcohol. It's in windshield wiper fluid, it's in paint strippers, things along those lines. Really toxic. So it is a primary alcohol. When it first reacts and it becomes oxidized, we take away a couple hydrogens. We take away this hydrogen and we take one of these hydrogens away, which is why it's CH2 now with a double bonded oxygen. And that's called formaldehyde. And then we can do it again by inserting an oxygen right there to make a carboxylic acid. Ethanol is another example. Once again, a primary alcohol. We took away one of the hydrogens from here and another one here to make a double bonded oxygen. Notice there's a hydrogen here, we can insert an OH group. It can act like a depressant, and it actually does a lot of harm in our bodies. A social drinker can drink 12 to 15 milligrams per deciliter an hour. That's about a beer an hour, and metabolize it safely. However, if you're an alcoholic, or if you know someone who's an alcoholic, they can actually take in, they actually have to drink more in order to have the same effect. Give you a general idea, after 1 glass of wine, you're rather talkative. After 2, you start getting giggly. Once you get up to 4 glasses of wine, you start getting tired. Once you get up to 8, you're definitely intoxicated. You can barely walk. Quick to anger. 12, you're unconscious. 16 to 20, and you're dead. Now, keep in mind, this is for a social drinker, a 150-pound social drinker. If you know someone who's an alcoholic, there's a good chance that they're able to consume more and not have the same effects. Now, thiols, remember there was 2 rules for thiols, or for oxidation. You had to be able to gain oxygen bonds or lose hydrogen. Now, with thiols, it's an SH. There is no oxygen here. So you will be focusing on losing the hydrogen. So if we remove these 2 hydrogens, you have a sulfur-sulfur bond, and that's still considered oxidation because you're removing the hydrogen. So let's review a bit. Whenever you come across these, and we want to figure out the products, the first thing you have to do is look at the starting material. If we're looking at this, you have a carbon here and a carbon group here. This is a secondary alcohol. Because of this, it's going to convert over to a ketone. These 2 hydrogens are going to go away and you'll form a double bond. This one, however, this is a primary group, primary alcohol. You have 1 carbon group attached to it. So that means this is a primary, which means that this actually looks more like this. Okay, there's our primary alcohol. One of these hydrogens are going to go away, and another one of these hydrogens are going to go away. It's going to form a double bond. So the first product is going to be an aldehyde. So this is B. The second product, we have a hydrogen here. We're going to insert an oxygen in the middle to form a carboxylic acid. So this is your C. So when it's a primary alcohol, you actually have 2 steps. When it's a secondary alcohol, you only have 1 step. So let's do this from scratch. 2-propanol. So, prop means we have 3 carbons. 2-propanol means it's on the OH group is on the 2nd carbon. All the rest are hydrogens. So that is our starting product for both questions. The first question is asking us about oxidation, which means we're going to lose hydrogen. There's our alcohol. We're going to lose hydrogen. We're going to increase our oxygen bond. So we're actually end up creating a ketone, and all the rest are hydrogens. And it stops because it's a secondary alcohol. It has a carbon group here and a carbon group here. Since it's a secondary alcohol, you only have one step. Now for the dehydration reaction, we're going to start with the same compound. And we're going to remove water. So the electrons that we're holding that together are going to end up bonding together. So carbon, we still have 3 carbons, except these 2 electrons that were bonded to H and OH are now a double bond. And all the rest are hydrogens. And there you go. Same answer. After oxidation, you have a ketone. After dehydration, you have a double bond. And that's the end of reactions with alcohols and thiols.